All right, here we go. Question 5 is where we're starting to actually get a little bit tricky with these questions. So we're going to use for loops to make a turtle draw these regular polygons. And here they've defined regular polygon for us. Regular polygon means all sides have the same lengths and all angles are the same. That's a useful definition when we use it when we're creating these polygons here. So we need to use a for loop to make the turtle draw each of these regular polygons all in the same program here, and we can do that. That's actually not too prohibitively difficult. So let's go ahead and get started. We're going to start by just importing the turtle method, the turtle module rather. Obviously is the place we need to start. We need to import turtle. We need to create a turtle. We need to create a string, or we need to create a screen and then create a turtle, and then we need to create a for loop for each of these polygons. So we're going to do exactly that. Import turtle module, and we're going to create a screen and a turtle. Then we're going for loop make a lateral triangle, a square, a hexagon, and an octagon. Alright, so there we go. So let's do these steps. First we need to import turtle. I'm going to go ahead and get rid of the comment. Generally speaking, we don't need to comment our import statement. Fine, just leave an import statement kind of sitting on its own there. We need to create a screen in a turtle. Our convention that we're using is WN for window, and then calling turtle module. And from within the turtle module, we're going to ask it for a screen object. We're saying, hey, turtle module, give us a screen object, and let me call that object WN. That's what we're doing here. And then we need to create a turtle. So I'm going to create a turtle. We're going to start with Leo. He is our turtle, so I say, hey, turtle module, gets me a turtle here, and names him Leo. So I'm going to really quickly just some things here. And there we go. I believe that is the correct line code here. Yep, that appears to work. And I'm going to make sure that I do really quick here. This, well. All right, good. Just the necessary steps that you have to take here to really achieve a perfect program is make sure that all your aesthetics are correct. And I have very particular aesthetic here that I'm going for. So I have Leo. I made him blue. I made him shaped like a turtle, just because that's how I like to have my turtles. And then I need to use him to make a for loop. Use a for loop for him to make an equilateral triangle, to make a square, to make a hexagon, and to make an octagon. Okay, so I need to think about how I'm gonna do this. Well, if we wanted him to do a square, is probably the start with, right? So if I was going to draw a square, what would I do? Well, I would draw a line, then I would turn 90 degrees to my left, and then I'd draw another line. I'd turn 90 degrees to my left, and I'd turn another line, and then I'd turn finally 90 degrees to my left and draw a final line. So let's do exactly that. We're going to start with the square here. We need to draw 4 lines, which means we probably want to draw it I in range 4, right? That's probably where we want to start out at. We can make these squares any size we want. Let's go ahead and go with 100. 100's a nice even number. So we're gonna say, hey, Leo, for 4 times, can you please go forward for me 100 units, and then can you go ahead, can you make a left-hand turn 90 degrees, right? As 90 degrees is how many degrees is in each right angle of a square. Hope that makes sense. Yeah, hope that makes sense. Um, so let's do exactly that, and that should just, if I run this, do it for us. Yeah, and there's Leo, and he's making that square for us. So there he is. He's done it. Knocked it out of the park for us. Fantastic, Leo. That's beautiful, lovely. Thank you, sir, for your service. Rather than making Leo do all the work, I'm gonna go ahead and real quickly just bring in some helpers to help Leo out here, and I'm gonna make sure that I set them up correctly. So here we go. We'll save that, and now I'm gonna use this other turtle that I just made. We're gonna call him Raph for no reason, no particular reason. We're gonna use him to make an equilateral triangle. So this is the same thing, right? If I wanted to make a triangle, an equilateral triangle, which is a three-sided regular polygon, I would go a distance, and then I would turn some number of degrees. I'm not sure how many, but it's something I can figure out. Turn a number of degrees to the left, and then go forward, and then turn a number of degrees to the left, go forward. So what do I need to do that? I mean, we could try to just figure it out, right? We could try to guess and check it. I know that I'm going to want to do it 3 times, because that's how many sides are in a triangle. So I'm going to ask Raph to go forward. We'll also send him forward 100, and then I'm going to ask him to turn left. I can't do 90, because 90 wouldn't be right. 90 would give me a square, so maybe it needs to be bigger than 90. I'm going to do 120, see what that gets. Maybe it needs to be bigger than 90. Alright, well that seems to have worked. So what would have happened if we made it smaller than 90? Say if I did 70. What does that do? Huh. Interesting. This looks kind of like the start of a pentagon almost, a 5-sided polygon. So it appears that the smaller the angle gets, the bigger the churn gets, and therefore the smaller the angle that we churn, the bigger the inside angle of the corner is, and therefore the more sides we're able to fit within that space. I wonder if there's a way to mathematically represent. Well, okay, so we know that we tried it out and we got 120 here as the proper churn for our triangle. So we did that, and that made a perfectly good triangle. So we used 90 for the square, and that got us a perfect square. So what can we do here? Well, we went 90 4 times. So there's 90 degrees here, 90 degrees here, 90 degrees here, 90 degrees here. That's 360 degrees overall. And with the triangle, we did 120 degrees and 120 degrees, 120. So that's 360 as well. So it seems like there's a mathematical relationship there where the number of degrees that you need to churn in order to get the correct angle for a perfectly sized regular polygon, it's actually 360 over the number of sides that you have. And so that should still get us a perfect square. This should still get us a perfect triangle. Save it and run it. And well, you know, it still works. So we found a mathematical representation. Well, that's going to make doing our hexagon and our octagon super easy. So let's, instead of making our turtles continue to run here, let's go ahead and get some helpers here. Let's get this guy. I'm gonna call him Donnie. Donnie is a perfectly reasonable name for a turtle. So we're gonna get Donnie out here and see what he can do for us. And for Donnie, we're gonna say, hey Donnie, and we can just take our code that we've written here and go ahead and get that set up down here. We're gonna say, hey Donnie, I need you to draw a hexagon. There's 6 sides of the hexagon, and I know that therefore the angle that I need to turn inside of my hexagon code is going to be 360 divided by 6 based on the formula, the kind of relationship that we figured out here. So let's run that. Does that work? So there's our triangle. Raph drew us a triangle. Leo draws us a square. And Donnie draws us a hexagon. Okay. Well, we're not going to make Donnie do all the work. He's already walked so much further than the other turtles have. I mean, Raph only walked 300 units. Leo walked 400 units. Donnie, he walked 100 units. Let's get a turtle in here. Let's get a turtle. We need to make him energetic. So let's go ahead and call our turtle Mikey, because he's got a long way to walk. So we want to make sure that he's kind of full with energy. We're gonna get Mikey out here, and hopefully Mikey can knock out this octagon for us. Instead of copying and pasting, I'm just gonna write it out for the extra practice. So I know an octagon has 8 sides, which means I know, based on what I've done previously, that Mikey needs to go forward. Mikey needs to go forward 100 units, and he needs to, at the end of each of his forward steps, he needs to turn left 360 divided by the number of sides, which is 8, and therefore get a triangle. We get a square, we get a hexagon, and finally, and this probably won't fit on the screen, we get, theoretically, a perfect octagon. It's just like Mikey wandering off outside of the window area, but we'll assume that he got it right. We'll trust in him this time. So there we go. Four loops to run through 4 different regular polygons. So let's see. We'll save it, and we'll see what their answer is. And they drew an equilateral. Oh, so they wrote separate code bits for each of these, which is fine. You know, they didn't do it all in the same program like we did, but that's okay. So they imported turtle, they created a screen, they created a turtle, and then they said for eye and range, move yourself forward, and then they have here the actual mathematical definition for vertices of a regular polygon, which I don't want to kind of break the fourth wall here and kind of ruin the illusion for you, but I did know that this is how you determine the angles on a regular polygon. Is doing 360 divided by the number of sides. So I don't want to spoil that for you, but I did know that was the case. So I didn't actually figure that out organically down here, but I had to play it up for the camera, you know, so to speak. So they figured that out here, and then they turned left 360 divided by the number of sides of the polygon. And then they also included wn.exit on click, which we should have included as well. It's just a good way, if you're writing a turtle program, to end the program up. Make sure you always leave that last white space for yourself at the end of the program. By Python conventions, that's why we do. We leave an empty line at the end of our program. And let's continue looking here. It looks like they did all the same things we did. 360 divided by 4, 360 divided by 6, 360 divided by 8. So there we go. Got all of our turtles in a row here, and they knocked it out for us. There we go. I'll see you guys in the next